Okay, we're going to do problem 17, chapter 4.6. A 36.5 kilogram sphere is acted upon by 133 Newton force directed along the positive x-axis. What is the magnitude and direction of a second force such that the sphere experiences an acceleration of 3.96 meters per second squared directed 21 degrees above the positive x-axis? This might be a two-parter, so let's go ahead and get started here. I went ahead and drew out the pictures of what you'll need. Just to save time, pause it if you want to copy this down. Okay, I wrote the positive y here, negative x, negative y. That's the directions they're using instead of north, west, south, east. One side I drew just the force vectors, and on the other side I am drawing the acceleration vector. My object is this circle in the center, and then the dotted pink line is just the x-axis. Just drew it out in pink. Here we have the first force, F1, of 133 newtons, going in the positive x direction. And then on the right here I have the 3.96 meters per second squared acceleration that results because some force 2 comes along and hits the sphere and creates this acceleration that we have over here. That's 21 degrees above the positive x. I have here, and I'll show you how I get that number. Let me erase that. So the F2 is going to come along with the F1 and create this F net. The F net creates this acceleration. So in order to find F2, which is ultimately the main thing, the second force, that's what we're trying to find, we must know the net force. To know the net force, we have to get that from the acceleration, because we do know the acceleration, we do know the mass. And so you're like, oh, now it might be clear. If you know the acceleration, you know the mass of something, you know its net force, because the F net, and I don't know if I have this wrote, the F net will equal the mass times acceleration. If you have acceleration, you have a net force acting on you. So you can do that. The F net will equal 3.96, which is the acceleration, times the mass, which is 36.4 kilograms, and I get the F net to be 144.54 newtons. So that's where I got that from. Hopefully that makes sense to you. If not, come ask. 144.54 newtons. Okay, now I know the net force. The net force is made up of F1 and F2. Alright, and that's what this equation is showing. The F net equals F1 and F2. I don't have a plus sign here, I just have an and sign because it's the components of the F force 1 and the component x and y components of the force 2 added together to make the F net. You can't just go F1 plus F2 because they're not in the same direction. With forces, you gotta have a magnitude and direction. You can only add them together if they have the same direction or opposite directions. Opposite directions you'd be subtracting. Okay, so let's go down, and we got to break our F net up into the F net x component and the F net y component. And I might have those backwards. I'm going to go back and erase those. Alright, so we have 144.54 newtons going this way. Up, it's at 21 degrees. I know it's 21 degrees because whatever direction my acceleration's in, that's the same direction that the force is, the net force is going. So we come back down here. Positive y is up here, positive x down here. So the y component of my net force is right there. It's opposite of the 21 degrees, so I'm going to use the sine trig function, the hypotenuse theta, to find the F net y component. So the force of New York. No. And down here we have the force in the x direction, the F net x component. and it's adjacent to the 21 degrees, so I'm going to use cosine 21. I accidentally wrote on my 21. That's 21 degrees. And so I'm just breaking it down. I did the number crunching already, and you will find that the y component of the net force is 51.78 newtons, and the x component of the net force is 134.939 newtons. Okay, so now we're cooking. We're almost there. We're halfway there. We have to find the F2 force, right? That's what we're trying to do. Okay, let me get rid of this for a second. Okay, so in order to do that, let's go back here. The net force is made up of the F1 and the F2. So if I take away the F1 from my net force, I'm going to be left with just my F2, right? So in order to subtract the F net from the F1, I'm just going to subtract the X and Y components of each. So the one component of the first force is just in the, go back up here, X direction. It's just going to the right, just in the X. So make this X. And I'm going to subtract that from my net force, X component. So let me plug the numbers in. This was 134.939 newtons. I'm going to subtract, and that was in the, I go back, that's in the positive X direction. If we look at our triangle, it went this way. That's positive X. The Y was in the positive Y direction. Okay, so that's a positive number. The force 1, its X component, was in the positive direction at 133 newtons. So I'm going to subtract the 133 newtons. That will equal the X component of my second force, right? So this guy right here has, let me draw the triangles out. He has some X component here, and he has a Y component, right? And if we draw a triangle with all these three combined, the F net would go like this. This little guy's Fx2 would go right here. And then the green force from F1 would go right here. And then the Fy2, Y component of the second force, would go right there. And we see that this triangle, it's a right triangle, it's made up of the X and Y component of F2 and the F1 component. Okay, so that's what we're doing here. We're just saying, oh, well this F net had an X and a Y component as well. This is Fx of the net and Fy of the net. We're saying, what's F1 minus this Fxn? And that should get us our Fx2. Okay, so the F1 subtract the Fxn, or Fxn minus the F1, we'll get this little part right here. So that's why we're doing this math here. And I'll get a calculator. So 134.939 subtract 133, we'll get 1.939 newtons. Okay. Now let's go back up to the triangle here. The Y component of my Fy2 is just the same as the Y component of my net force. So all I got to do is just copy it down. So, alright, let me switch to blue. So my second force, its Y component, will equal the net force's, the net force's Y component, which is 51.798 newtons. So now, we're getting there. So now the second force, we know its components. We know that its X is this little bitty 1.939 newtons, and we know that its Y is made up of 51.798 We just got to find this angle that's coming in at, theta, and we got to know its magnitude. That's what we need to find. To find its magnitude, you're going to use a squared plus b squared equals c squared. And to find theta, you're going to use your trig functions, right? You have the opposite and adjacent, so tangent -1 of opposite, which is 51.798 over 1.939. Okay, I'm running out of time here, so hopefully if you can get to this step and see how we got there, you should be able to solve the problem.